Hello and welcome. In the previous video, we went over the basics of ISIS. We explored the lab environment, and now we are ready to configure every router from that topology. So let's go and start playing with ISIS in RouterOS. Okay, so now that we understand the basics about ISIS, we are going to go router by router performing the configuration. The final goal is to have those local area networks on the left and on the right with IP connectivity. So I'm going to start at the center, so with R1, so I will simply click on that device, and I will have access to the terminal, to the CLI. Also, you can access the terminal from the Winbox. So first of all, I will check that all the IPs are in place. So we can see here that we have 3 interfaces with 1 IP each. And we can see that the interface that is connected to Internet, Ether 2, has an IP. Then we have an IP on Ether 1 that is connected to Ether 2. And finally, we have Ether 3 that is connected to Ether 5, also with 1 IP address. So that's all that I have in this device. So we want to configure ISIS. We simply need to go to routing and then ISIS. And then here, as we have seen before, there are basically 2 things that we need to configure. So the first one is to create the instance. And to create the instance, we are simply going to go to instance. And then here we are going to say add. And then if I press tab, we're going to see that there are multiple options. So first, we are going to add a name. So I'm going to type name, and then I will type just a simple name like instance-1, for example. Then we need to place the router into an area. So we check the network diagram. This area is 49.0002. So basically, I will come here and I will say areas. And then this is going to be equal to 49.0002. And finally, if we continue exploring the different options here, so we have the family address for the addresses. So in this case, we don't need to include that, but also you can do IP if you want, but that is going to be optional. So we have the areas. Something that we must provide is the system ID. So according to our network design, the system ID is going to be quad zeros dot and then 000R. So here we're going to have 3 zeros and then R, where R is the number of the router. So I will go back to the router, and I will simply say system ID is 0000 dot 4 additional zeros dot 000, and this is 1, because this is router 1. I will press enter, and if I go to instance print, then we see that we have now created an instance of ISIS. Basically, this means that ISIS is available, is running, but then we need to map interfaces. And we have to say, okay, this interface is going to be mapped to this instance, and then we are going to select the level of routing that this device is going to be working on. So we check the diagram. This router is going to have Ether 3 and Ether 1 running ISIS, and both of them will be level 2 interfaces. So that means that they will be performing level 2 routing. If we have local area networks here, we will need to have those interfaces as level 1, level 2 to be able to exchange that information within the area. But in this case, they will be simply level 2 because we have the local area networks here on the left and on the right. So to be able to map those interfaces, we are going to use interface templates. And then we can simply come back. And now we're going to go to routing ISIS and then interface template. Here we're going to add those 2 interfaces. So we're going to say add. And then if we explore the different options, we can see here that we can set the levels. So we can set L1 for level 1, L2 for level 2, or L1, L2 for level 1 and 2. So in this case, levels is simply going to be L2 because we only need L2. And then we need to map the instance. So the instance is going to be the instance that we have just created. And finally, we're going to pick the interfaces. So we have to tell, okay, we're going to be running ISIS on these specific interfaces. So we'll say interfaces. So in this case, it's Ether 3, Ether 1. So basically, that interface here and that interface there. And now we can simply press enter. And if now I print that, so you can see that we have those interfaces running ISIS, and they are with level 2. And additionally, if I go to the instance and I print that, we can see here that the system ID has been set, the area has been set, and the name for that instance is instance 1. So in this moment, this router is ready and is able to establish an ISIS adjacency with any neighboring device that is also running ISIS. So we're going to continue with the configuration, and now we're going to configure R2. And then we're going to have our first adjacency in ISIS. So let's go to R2. You can see that this device has 2 IP addresses. So one IP address that is talking to R1, and the second IP address that is talking to R3. So that's all that I have in that device. So same process, I will go to routing and then ISIS. Step 1, we need to create the instance. So we're going to say instance. We are going to give it a name. This is going to be instance 1. And then we have to set the system ID. In this case, this is the router 2. So we are going to have all zeros, and just the last digit is going to be 2. And then we have to set the areas. So in this case, R2 is also in area 49.0002. Now I press enter. And the next step is to map the interfaces. So now I will go to interface-template. I will add a new template. So the level is going to be L2. The instance is going to be the instance 1. And then the interfaces, according to the diagram, we have ether1 and ether2. So I will add ether1, comma, ether2. Now if I press enter, we have R1 and we have R2 running ISIS. So as simple as that. So we have now ISIS running between those 2 devices with level 2 routing. So if I want to check the neighbors, I can simply go to routing ISIS neighbors. And if I print that, so you can see here that there is one neighbor. So we can see here the system ID. We can see that the state is up. And also we can see the adjacency type, in this case level 2. And also we can see the interface, so this is on ether 1. And basically this is how we have created that adjacency using level 2 routing. So still we are not propagating any additional networks. We only have that neighbor adjacency that is being established between R1 and R2. So if I capture packets that are going out of this ether 1 interface, we should see some messages for ISIS that will include some information about the process that is running between those 2 devices. Then we're going to see also how to check the LSPs, that basically is all the information that is being generated by every router, and it's going to be the database that those devices will have. So in this case, those are level 2 devices, so it will have only one database for level 2. So if I filter here the messages only for ISIS, you can see there are multiple messages that are going back and forth. I will select this hello, for example. So you can see here that we don't have IP because this is running on CLNS, no IP, we have explained before. And we can see this is an ISIS hello. We can see the system identifier here. This is from router 2. We can see the hold time and basically multiple fields that are mapped or related to this process. So basically, now those devices are able to discover neighbors out of that link. In ISIS, there is only 2 network types. Broadcast, that is the default behavior, and the next one is point-to-point. So there is no more than that. So you can see that is a lot simpler than ospf. So in this case, we're going to keep the broadcast network type, the one that comes by default. And then in the upcoming series related to ISIS that we're going to have here in the channel, we are going to dive deep into this process. Now we're simply getting familiar with this protocol that has been added recently into RouterOS. So now let's continue and let's go with the next device. So now we're going to go to R3. So R3 belongs to a different area. So remember, in ISIS, a router belongs to an area. If I go to IP address and I check the IPs, we can see that that device has also 2 IP addresses, the one that is connected to R2 and the other IP that will allow the connection to R4. So now let's go to routing, ISIS, and then instance. So now we're going to create the instance, and we're simply going to say name is going to be instance1, and then the area for this one is 49.0003, and the system ID is 3 groups of zeros and then 0003. So now we are ready to create the interface templates. But in this case, we have to check that this device, so now we are in R3, so this device has one interface that is performing level 2 routing and one interface that is performing level 1 routing. So we need 2 interface templates, one per level. So let's go to the first one. So here we're going to say, we're going to go to interface template, and we're going to add a template. So we're going to say the interface iter1. This is going to be level 2 because this is connected to R2. And the instance is going to be instance 1. And then the next one is going to be level 1. So add interfaces. So in this case, iter2, this is going to be L1, level 1. And the instance is going to be the same ISIS process. So now we are ready with R3. If I come here and I check the neighbors, we can see that we have one neighbor. And that is out of iter1, there is a L2 adjacency. So because this is between areas and we are running only level 2 routing there, so we can see here the ID from that neighbor and the state is up. So everything looks fine until this point. So the next one. So now we need to create an adjacency between R3 and R4. They are in the same area and they will be performing level 1 routing. So let's go to R4 and we're going to go with the same process. So if I go IP addresses, print, then we can see that we have 2 IP addresses, the local area network and also the network that is connecting to R3. So same process than before, routing, ISIS, instance, and we are going to add an instance. So the name instance 1, and this is going to be on the area 49.0003. And the system ID for this device, that is router 4, is simply going to be 2 groups of zeros and then 0004. Now we can press enter and we have an instance ready in this device. So in this case, R4 is just within that area, is not part of the backbone, so we need only level 1 routing. So that's why I will go here to interface template, and then we are simply going to have one template. And that template is going to contain the interfaces iter1 and iter4, because those are the ones connected to R3 and to the local area network. And then I will say that the level is L1. And now we need to pick the instance. We are going to be using the instance 2. So in this case, it's instance 2. So there is a type on the name. So I have to map the correct instance. And then if I go to neighbor and I print that, we can see that this device has a neighbor from R1 to R2, from R2 to R3, and from R3 to R4. So from R1 to R2, that is a level 2 adjacency. From R2 to R3, that is a level 2 adjacency. But from R3 to R4, that's a level 1 adjacency. We can clearly see that by checking here the level type. So if I come to IP route in this device and I print, so we can see here that there are multiple entries that contain this I. So we have dynamic, active, and ISIS. So we can see that the I stands for ISIS. So that's a new flag that we have in RouterOS. So Mikrotik has released this feature just a few hours ago, and still you are not able to see those flags in the Windows. So probably now that you're watching this video on YouTube, you are able to do it, but at this point that is not possible yet. So now we have that adjacency, so we can see routes coming via ISIS. If I want to see all the database for the LSPs, so we can simply come here to routing, ISIS, and then you can see here different options for the menus. So if I go to LSP and then print, so you can see here that we're going to get the database, so the link state packets that all the routers have created. And basically every router that is running ISIS is going to create its own LSP, and then it's going to send that with information. So now let's check what we can see in R1, because now we have full adjacency from R4 all the way up to R1. So let's see what R1 has in its routing table. So I will come here to IP route, then print, and then we can see that R1 is receiving that information. So what is happening now is that between those devices, we have level 1 routing. So R3 must inject that information into the level 2 routing chain. And here we have level 2 adjacency, a level 2 adjacency, a level 2 adjacency. So basically that information is going to be sent throughout that level 2 chain. So that information is going to hit R5, but then R5 has a neighbor, and that neighbor is going to be just level 1. So R5 is not allowed to send level 2 information into the level 1 database. So if there is an entry that must be sent to the device, so this device is instead going to inject a default route. And then this device here is going to be able to reach the rest of the network, but by using that default route. So we're going to see that in action just in a bit, because now we need to configure R5 and then R6, and we're going to have our full topology working with ISIS. So now let's go to R5, IP address, print. So we can see that there are two IP addresses in R5, the one that is connecting to R6 and the other one that is connected to R1. So we're going to go to routing and then ISIS, and we're going to go into instance, and we need to create an instance. So we're going to say instance 1, and the area here is going to be 49.0001. And then we're going to set the system ID. So in this case, this is R5, so it's going to be two groups of zeros, and then 0005. So now we have the instance. So the next one is to create the interface template. So we're going to go back one level, and then we're going to get into interface template. R5 is going to be performing level 1 and also level 2 routing. Ether 1 is going to be connected via level 2, but Ether 2 is connected to R6 using level 1 routing only. So I'm going to go on, I need to create two interface templates. So the first one, so I will say interfaces, this is going to be Ether 1, and level here is going to be L2 because this is connected to the backbone. And then the instance is going to be instance 1. So we have that command here, and now we can simply press enter. And then for the next one, we are simply going to say, okay, the interface Ether 2, this is going to be level 1, and the instance for this one is also instance 1. And now we can press enter, and we are ready to check the neighbors. So if I go to routing ISIS neighbor, print, so we can see that we have one adjacency, basically adjacency that is going from R5 to R1. Then at this point, if I check the routing table, so we can see that we are getting information. So we can see here that we have the network 192.168.40/24. So that means that R5 is able to talk to this local area network here. So if I come to R5 and I ping 192.168.4.1, so we're going to see that R5 is able to talk to that local area network on the right. And then we're missing only one router, and that is R6. This has two interfaces performing level 1 routing. IP address, the IP6.1 connected to Ether 4, that's the local area network, and then 5.6 connected to Ether 1, that is talking to the router R5. So now we're going to go routing, ISIS, and then instance, and we're going to create a new instance. So let's call it instance 1, and this is going to be on the area 49.0001. And then the system ID is going to be two groups of zeros, and then 0006. Actually, we can have duplicate systems ID between areas, but as a good practice, we're going to keep that system ID unique across all our ISIS domain. So the next one is to create a template. So I will go up one level, and then I will go here to interface template, and we're going to add a template that is going to include the interfaces iter1 and iter4. And then we're going to pick the level, that in this case is going to be L1. And then the instance is going to be instance1. And then we have that command here, enter. And now, if we check the neighbors, so routing ISIS neighbor print, we have one neighbor. So the adjacency has been established between R6 and R5. And if I go to LSP and I print the link state packets database, so we're going to see here that we have a database for level 1. So we can see that everything is level 1. So remember, a router that is only with level 1 routing will only have one database, only for level 1. That is different, for example, for R5, because R5 has level 2 routing and also level 1 routing, so it's going to have two different databases. The level 1 database will be used for routing within the area, and the level 2 routing for inter-area routing. So now let's check if we are able to talk from that PC here to that PC on the left. So we will come here to the PC 7, show IP. So we can see that this PC has IP 6.10, gateway 6.1, and if I go to the next one here, so that PC has the IP 4.10. So we have one on the right, and we have the next one on the left. So I'm going to ping from this device the IP 192.168.4.10, and we have network connectivity. In summary, we have IP connectivity between all the networks that are participating in this ISIS domain. So if we trace the traffic, we can see all the routers that are being traversed by that traffic. So now we have ISIS working in our topology. Obviously, ISIS is a large topic. We have gone through the basics, but now we are missing just one piece. So here, R1 has a connection to internet. So how can I make that connection available to the rest of the routers? Because even though that R6 now has a default route, R5 doesn't have any default route, because remember, the default route is being injected from the routers in the level 2 that are sending information to the level 1. Because they won't inject the level 2 database, they will simply put a default route. So for example, if I come to this device and I send a ping to 8.8.8.8, so you can see that we are not able to send traffic to internet. So we need to go to the router where we have a connection to internet, so in this case R1, and we need to redistribute that default route. So let's go to R1 and let's see how we're going to do that. So I'm going to come here to routing, and then ISIS, and then the instance. So currently we have that instance. What we're going to do is that we're going to modify that instance, and to that we're simply going to type set, and then here under set, if I press tab, you can see a bunch of options, but one of those is going to be originate default. So you can see that one here, L2.originate default. So basically we're going to say L2.originate default, and here we have options that are quite similar to ospf. For example, always, that is always going to inject that information. If installed, if there is an active default route in the routing table, then ISIS is going to propagate that information, or never. Basically, this is pretty self-explanatory. So in this case, we're going to say if installed. And now I will press enter. This is going to be applied to the 0. That is the unique instance that we have. And now if I print that, so we can see we have the name, we have the system ID, we have the areas, and we have the originate default. So that means that now all the routers will have that default route. If I go to R5, so we can see here that we have a default route. And if I come to that PC, and now I repeat that ping. So now you can see that this device is able to go to internet. And also, if I try to ping that computer on the right, it still is able to talk to that one. So let's go back to this PC that is connected to the area 3. So let's go back here and let's check if that device is also able to talk to internet. So let's say ping google.com. You can see that we are able to talk to Google. And also, if I send a ping to 6.10, also we have full IP connectivity. Thanks to Mikrotik for including ISIS in RouterOS. This is going to bring a lot of advantages to service providers. And I'm sure that Mikrotik will continue adding more features to the routing protocol. This is the first ISIS lab in the channel. I hope that this video has been informative for you. Remember to get subscribed to the channel, click on the bell to get the notification for the content. And if you think that this content can be useful for someone else, remember to share it in your social media. Thank you, and I see you on the next one.